this second session of today's counseling session. Before starting the session, I would like to take this opportunity to introduce Dr. Tanushree to all of you. First, I welcome you, Dr. Tanushree.
Thank you, Sharad.
Thanks also for your continuous contribution, involvement in this unique initiative as you are from in this stream from since inception.
Yes.
I would like to take this opportunity to introduce to you to all our learners who is attending or who is going to watch this session through our YouTube channel. Dr. Tanushree herself is now Associate Professor at Civil and Environment Engineering Department, Birla Institute of Technology, Mesra, and MSc is Environment Science from University of Kalyani, West Bengal, MPhil and PhD from Jawaharlal Nehru University of Environment Science. And, before she joined in this BITS Pelani, as you know, when we were developing postgraduate diploma in sustainability science in that time, she was assistant professor in the postgraduate department of Environment Science and Technology, ISTA, Gujarat, means Institute of Science Technology for Advanced Studies and Research. She's a dedicated, hardworking research scholar. Still, I hope she is maintaining that and producing a lot of students and has a lot of publication in her area of interest. And a few of her achievements are: she is India Research Fellowship Award of Australian Ministry of Education 2015, recipient of Rashtriya Gaurav Award from India International Friendship Society 2017, recipient of Women Achiever Award from Venice International Foundation 2017. These are a few of the important awards she has received. There are many more awards in her name she received. And she has more than 50 publication peer-reviewed journal. That's also in high impact factor. And she's also a reviewer of a number of high impact factor journal, like, this is published by Elsevier, environmental monitoring and assessment. With this brief introduction, I welcome you again, Dr. Tanushree, in this session, and hand over to you to start the session.
Thank you, Sharad, for this lovely introduction. So, students, let us start today's discussion. Just one thing I want to know: have you gone through this unit, the material of this unit? Or another thing I want to just inform that at any point of time, you can stop me and ask any questions you want to ask. Okay, or if you want to contribute anything or add anything, you can.
Tanushree, that question will take in the end of the session, because
okay, fine.
Let us have a continuity in this recording, right?
Okay, sure. Okay, then we'll start rightly. Right now, the topic of discussion, which is sustainability issues related to energy and mineral resources. I think in the last 1 hour, you have given an idea about what are mineral resources and the types of resources, what are energy resources. So, I'm not going into detail of that classification of energy and matter. But yes, for achieving sustainability and the very goal of sustainable development, which is the pillar of environment, society, and economy. So these two things, these two resources are absolutely important to balance these three. Energy requirement, which is essential for development, materials, which are essential for development. So their proper use, the sustainable use is absolutely essential to achieve the goals of sustainable development. Now, to start with, the environmental perspective of laws of energy should be talked about. When we talk about energy, so the fundamental law for energy is, of course, the laws of thermodynamics. especially which deals with the flow of energy and the conservation energy and also the loss of energy. And in the first law of thermodynamics, it talks about that energy cannot be created and it cannot be destroyed. It can flow from one form, it can convert from one form to another form, and it will flow. So basically, it is the law of conservation of energy. And second law tells about that when, according to first law, as we know, the energy is always open loop. The energy cycling kabhi nahi ho sakta hai. It will never happen because it's a open loop, because it can convert from one form to another form, and during this conversion there will be loss of energy because there is work to be done, and there will be loss of energy mostly in the form of heat, and so the quality of energy will decrease when it is flowing from one form or converting from one form to another form. So more the energy is used, more will be the loss, and more low grade energy will be added to the environment. For example, when we are lighting a bulb, as you can see in this picture, then 95 units of the energy is consumed to heat the filament, and 5 units is used to generate the light. But the main aim is to generate the light. So only 5 units are being used up to generate the light, and the rest, almost 95% of the energy is used to heat up the filament which will generate the light, and that heat is lost. That heat is lost in our rooms wherever we are lighting the bulb. So that is the loss of energy. So here, according to the first law, electrical energy is converted to the light energy and heat energy. Light energy is being used and the heat energy is of no use, it's being lost. So this heat energy which is being lost by lighting a bulb is actually is governed by the second law of thermodynamics, and we can say that as low grade energy. So am I clear? Because these are the fundamentals of physics, and this is absolutely essential to understand if we want to get the idea why this energy conservation is needed and why this energy is being lost. So whatever energy is in demand, that very little of that is being converted into useful energy, and most of them are lost as unused energy. That is what I want to emphasize by discussing the laws of thermodynamics. Similarly, in natural systems also, I have given you the example of man-made system. In natural system, like in ecology, also you will see the here in natural system, the energy, the ultimate source of energy is solar energy. So when that is trapped by a plant, that is, if we consider that entrapment as 100%, so that energy which is trapped by the plant is used up by the plants, and there is respiration, and then when the so some energy is lost for plants respiration, other metabolic activities, and rest of the energy is in there in the plant. But when a herbivore, as you can see here, is eating the plant, just a minute, is eating up the plant, so only 10% of plant's energy is being converted to the herbivores. And similarly, when so only if the plant is fixing 1000 joule, only 10 joules are being converted to the herbivores. And if we move up, that is, if we go to the carnivores, then even again 90% is lost, and only 10% is being converted, or 10% is available for the food as energy from the herbivore to a carnivore. Uh, then the question arises, if there is so much loss of energy, then how this carnivore is getting their energy requirement? Can anyone answer this question? Because there is so much loss of energy. 90% of the energy is lost from when it is moving from plant to herbivore, herbivore to carnivore. 90% is lost. Only 10% is getting transferred from one trophic level to another trophic level. But still we know the herbivores and the carnivores. Herbivores, in this example, deer has to run, it needs energy. Carnivores, they have to catch the prey, they need energy, and they need huge amount of energy. But how this is working, then how these carnivores are getting their energy, from what source? Can anyone tell me the answer? Any? Yes.
Could be water or the atmosphere, direct respiration process.
Not exactly. Respiration is the process to convert the energy in heat energy or useful energy. But in this case, because the carnivore is not taking its food from only one source, it is consuming from various sources. And that is why it is meeting its energy requirement. Okay. So the basic concept is when you need useful energy to be, which is being utilized, you have to consume more and more, because the carnivores, they don't eat on only one type of food. They eat from variety of sources, and they consume more. They more and more they consume to maintain their energy. Similarly, the exact concept is in our society. If our society is such that we are living in a very energy intensive society, which our energy demand is very high, we require more and more energy because we use many electrical appliances, for example, in our daily lives. We need central heating, so we need more and more energy from one source, from the society, from the electricity, in form of electricity consumption. Then the loss of energy will be also very high. So this is exactly what is happening in nature, and this will exactly happen in our daily lives. But in case of matter, it is a different situation. When we talk about material resources, mineral resources, then it does not disappear. Once on the Earth's surface, it can be recycled. It is like energy, it is not lost when it is being converted from high quality matter into low quality matter, or it can be dispersed, it can be transformed into low quality matter, but it will not disappear. It will remain on the Earth's surface. Similarly, for example, the high quality matters are your pure metals, pure fuel, pure drinking water, whereas the low quality matter are ore, which is impure, because you have to convert the ore into pure metal. So low quality to high quality conversion again needs lots of energy input, lots of technological inputs. And when we are polluting, then you are actually contaminating or making a high quality pure water into a low quality water. So these pollutants are low quality matter, impure fuel, impure water, which can have huge health effects, impure fuel, which can give out many greenhouse gases during combustion. So these are the cases where low quality matter is not actually needed, or it is not preferable. Then the disposal and treatment of waste, which uses lots of high quality matter, because our end product, our finished product, which we use are actually the high quality products, because they are converted in from the low quality to high quality products. For example, if there is ore, you are extracting the ore, processing the ore, and you are extracting the pure form of metal, then you are processing it to make any product. For example, if your water body is contaminated, so you have to treat that water in a treatment plant, then you can supply the water as drinking water. Okay, so and when you are again discarding the high quality matters after use, if we are throwing away the waste generated in our household, even aluminum can or maybe the plastic bottles which came from plastics come from processing of the fossil fuels. So when we are throwing it away, we are actually throwing the high quality end product. Disposal of waste or treatment of waste is actually again we are ending up with thrown away high quality matters which is to be treated again and which is to be maybe recycled again. That we'll talk about recycling and reuse later on. So the identifying the usability, utility, and harnessing the potential of the matter is very important. And one of the thing is if we reduce the low quality matter generation, so we can automatically reduce the cost. We can automatically reduce the pollutants, because pollutants, as I said, it degrades the quality of the high quality matter. So if we can identify how or why we have to reduce the low quality matter generation, then sustainability can be achieved. So we'll talk about some examples of that. Let us continue. This is most not only that, in the previous slide, as you can see, so one is transformation of high quality to low quality. Another is matter can be dispersed also. For example, when ore after mining, it is being processed. During transportation, some matters can be lost during the handling, during the loading, during the unloading process. Some material will be lost, and once it is lost, if it is in the form of dust, it will go in the atmosphere and it will dilute and it will disperse away. Then during the processing also, after extraction of metal, there are lots of pollutant or lots of waste which are being generated during the cleaning process. Lots of wastewater comes out. So during the processing of the high quality, low quality matter to high quality matter, lots of matter is being dispersed also. See, so when from mining to the final product, so lots of matter is being dispersed, and us dispersed matter ko if you want to again collect and you want to reuse them, then you have to again invest energy and money, which is excess energy means excess demand on the energy means promoting pollution, and excess money, so you are pressurizing the economy, which is non-sustainable. Now I can give you one example, like in the thermal power plant. Let's take the example of thermal power plant. In thermal power plant, yeah, what is the raw material? It's coal, which is being burned. And after burning of this coal, the end product, of course, the heat is used to boil the water, which in turn will run the turbine and it will produce electricity. But the end product is ash. Ash, which can be bottom ash, which can be fly ash. So these are dispersed. This ash is dispersed, and if you want to collect this low quality dispersed matter, what you have to do, you have to install electrostatic precipitator or bag house or filters to catch this fly ash. And you have to think what to do with this fly ash. So either you are going to dump it, or you are going to use it in concrete making, brick making, or road construction, or in any other thing. So so to capture this dispersed material from high quality matter, when we are processing the high quality matter, in this case coal, when we are fly ash is a dispersed material. To capture that, you have to invest money, you have to invest energy, and again you have to dump them, you have to use the land resource. Again, you have to think of its reuse so that it doesn't create any environmental problem. So lots of excess energy and money is needed. What if the fly ash is not even produced? If we come with a technology, so trust should be that this dispersion of matter is minimized, and the transformation from high quality to low quality is minimized. How will explain? I will explain with lots of examples. Now, the depletion of energy resources. In case of this, we are talking about matter, the basic concepts of matter and basic concepts of energy, how they are lost, how they can be dispersed, how they can be recaptured. But now, let us talk about the conservation measures and other sustainability measures to reduce the depletion of energy resources. So one, energy is transformed, it is lost forever. We have now, by now we have understood that. Waste heat can never be reconcentrated. Like matter, अगर dispersed matter को आपको reconcentrate करना है, there are ways which are energy intensive, technological intensive, but for waste heat, once it is lost, we can never reconcentrate that. So the only way is to use a major source of renewable energy. If we are using renewable energy, then it is because if you're, I think you all know what is renewable and non-renewable energy. Non-renewable energy are can be regenerated in a lifetime process or in a stipulated time period, because the fossil fuels which are non-renewable, it takes millions of years to develop fossil fuels, but when we are burning it, within few years we are exhausting the resources, and when you are exhausting it, you need another million years to generate that resource, so which is a huge time frame, and it becomes non-renewable. And whereas the solar power, the biomass, hydropower, wind, and they are mostly driven by the solar power. Sun, because of the sun's heating, the pressure difference is created, and wind is blowing. Because of the biomass can be regenerated, if it's plants, they can be regrown. If it is hydropower, it is water is part of hydrological cycle, so it will be recycled. So these are the options which are renewable in nature. So these are one of the good options by which we can stop the depletion of energy resources. There is so much hue and cry about the coal resources right now. I think you are all aware of it, because the coal resources, burning of coal is producing huge amount of pollution, and also the huge amount of emission of carbon dioxide, which is not only responsible for the global warming, but also the dust generated by the coal thermal power plants and the mining. Due to coal mining, it's degrading the air quality. So now there is a huge cry worldwide that the coal energy should be replaced by other energy. So what are the options? Only the non-renewable, renewable energies are only the options. Well, this is one of the graph of last 20 years for India. The source is from IAE organization, and this graph shows that still this blue is coal. This is coal. This is coal. Still in 2020, जैसे time आगे जा रहा है from 2000 to 2020, still that coal dependency is growing. Okay, and this is oil. This is oil. This dark blue color is oil. So both are fossil fuel. So we are almost 70% of our energy comes from fossil fuel, um, burning or fossil fuel processing. I mean, the use of fossil fuel to generate the energy. So coal and till now oil is the major sources of energy in India. This is total primary energy demand in India from 2000 to 2020. And you can see that these are natural gas, which is again fossil fuel. Then these are traditional biomass. As we are, this is biomass. As we are moving, we our dependency on biomass is decreasing because biomass means solid fuels like the cow dung cakes, like food. What is happening because most of the in the rural areas these are used for cooking in indoor setup. So lots of indoor pollutants are being generated and people are getting killed and they're having serious respiratory illness, especially women and children. So the conversion is what the option is to provide LPG, which is a cleaner fuel than the solid fuel. They can be used. So especially for cooking purposes, household purposes, biomass burning has been reduced, and other sources which are our non-renewable, renewable sources, that percentage is still very low. But still the demand for all the fossil fuel is still very high throughout the year. But now the shift is we have to live in a coal-free society. So India has demanded that please give us some time because we are totally dependent on the fossil fuel and majorly on coal. So the shift will take time and there will be phasing out of coal by 2050 and by 2070, the total phase out. Anyways, so this is as we are going to use more and more fossil fuel, it will deplete. So the only option is to use the renewable sources to reduce this depletion because renewable sources are never going to deplete. Now this for resources, this is a concept of bubble pattern. As we have seen also in the previous slide, in India, in the last 20 years, still the demand is increasing and the demand of fossil fuel is increasing. Now, if this is an typical example of US petroleum use, right from the start of the industrial era to right now, and even in the future prediction is there. So this kind of pattern of utilization is known as bubble pattern of resource depletion, which was first given by Huberts. And what is it? It is, you can see the demand here. Yeah. Yeah. As the years are increasing, the demand was very low at initial, but as we are increasing, our industrialization is going on. This is the example of USA. And then when it peaked because the lifestyle demands, the society is more energy intensive there, and the demand for industrialization, for development, it peaked just like a bubble grow. And then now what is happening, it is being exploited very quickly and unsustainably because the concept of sustainable was not even there in the early 90s or in the mid 90s. The legal implication was not there, and the exploitation was exponential. As you can see this part, this is exponential growth, and the supply is much more of the demand because there was ample supply. resource was available in very high amount. So the demand was also, the supply was good enough to meet the demand, the supply was more to meet the demand. And then after this peak, now the trend is reverse. So the demand is very high because by now, for everything, each and everything, for household work to industrial work to commercial work, for everything energy is needed. So that now the demand is very high and the supply is less. So there is an exponential decline of these resources. Resource is depleted now. The resource is not available now. And this is called the bubble pattern of resources. There will be exponential growth of the demand, and the resource will be consumed, and then the resource will decline, but the demand will increase. That will give you a exponential decline in the resource. So resource will be quickly used, unsustainably used, and it will not be left for the future generation. And as the resource is diminishing, for example, the coal stock is getting depleted. So you now what is you by applying technology, you want to increase your efforts to extract more resources, produce and you invest more and more to find where are the other coal resources or oil resources. You will invest more on exploration. You will invest more. Kahin pe bhi mila, anywhere you will get a resource, you will go there and you will excavate that. So you will invest more, but your returns are less because the resource itself is getting depleted. So there will be returns will be less. So they economically also it will not be viable. So that is law of diminishing return. So what is the way out? Way out is conservation of resources, of course. Now, not only there are three ways. One is conservation, one is preservation, and one is restoration. Now, conservation is lower resource use, which is a sustainable thing. Preservation is you're almost worn out of the resources, and whatever thing is left, you're preserving that, you're not using that. Okay. So until and unless you have alternatives, preservation is not possible. And restoration is you have almost degraded all the high quality resources. Now you have to restore that. You have to rebuild that. For fossil fuel, even restoration is not possible. Now, saving energy is the leaner way. Efficient use of energy is the keener way, and sustainable use of renewable energy or sustainably using the non-renewable energy is the greener way. Low emission energy is the cleaner way, and high emission energy is the meaner way. It's not at all sustainable. So as we are going up, these are becoming more sustainable. Now, how to do this? First is there would be energy consumption per capita should be reduced. For material also, use of efficient material, the technology which helps to efficiently use the material should be used. Like Japan converts 70% of the raw timber into finished wood products, while USA converts only 50% of the raw wood into converted product. So of course the material use efficiency is more in Japan, which and this also implies that high grade to low grade conversion is less. This also implies that dispersion of timber is less because we are getting more finished products. So that is material efficiency. And energy intensity index is if we consume less, the energy used per capita is less, then the energy used is less. And of course, this is what is the, so efficiency improvement is one of the major uh, way out to conserve the resources. uh, let us see one example. We know in our automobiles, some log in Indian mentality, first we ask that what is the mileage. Why? Of course, that is pocket friendly if the mileage is more. But there is another aspect also. If the mileage is more, that means that you are consuming less and less your non-renewable energy, and you are getting the same output. So this is less energy intensive. So in a way, you are efficiently using the energy. And so much of vehicle standards, so much of engine efficiency, so much of lightweight vehicles, these are actually creating the energy efficiency. So preferring a vehicle which use the energy efficiently is not only the thing that it gives you, it's not only that it is pocket friendly, it is also energy efficient. Okay. And for example, in materials like use of sustainable use of water is an efficiency improvement. This drip irrigation, आप pump से अगर you're doing the irrigation, it uses gallons of water. But if you're irrigation is done by with a drip, then it is less water intensive. Similarly, now there is airdrop irrigation system also, which captures the humidity from the air and it condenses into water, and then it is supplied at the root level of the plant. And there can be micro irrigations where in the supply pipes there are small holes, and it can sprinkle the water, and less water is being sprinkled, so less and less water is being used. And then the of course the concept of reuse and recycling. The same resource can be used again in the same form, that is the reuse. And we know that in our house maybe many items come which can be reused, like bottles, like cans, like the packaging bottle of a particular thing. Uh, and recycling is resource not reused in the same form. It is converted into different kind of product, or the waste can become a raw material of other product formation. Okay. And there is pre-cycling also, which is conservation by increased efficiency. Like if we use our efficiency, then there will be a conservation, the energy itself will be conserved. How? I will show you the examples. And we know in case of solid waste, like for example glass bottles, they are consumed, they are collected, and they can be recycled. They can be reused also, the glass bottles. So in a turn, you're not throwing it away after one use. So this will be a good option to recycle. For example, aluminum cans. Aluminum cans can be recycled in a much more efficient way, because the extraction of ore of aluminum and converting that aluminum ore into finished product requires huge amount of energy. But recycling of aluminum can save up to 90% of the energy cost as compared to the virgin aluminum. And it can also reduce the air pollution by almost 60 to 70% as compared to the virgin aluminum production. And so it's not only the recycling of material, it is also the reduction of pollution in question. Okay, and the recycling loop is only closed when the same product is being discarded product is turned into new and same product without loss of its property, and it is again repurchased. So then only this loop will be closed. So from if the recycled products are repurchased, then it is only a successful recycling. And another way is substitution. So one of the resource is used instead of another. For example, aluminium, which I said is very easy to recycle, so it can be used in case of in as a substitution of copper wires in electric appliances. Paper can be reused as a substitute for plastic, because plastic is coming from your, it's a byproduct of fossil fuel. Okay. Uh, so if it's a byproduct of fossil fuel, then of course it is coming from a non-renewable resource. So but paper, which is made by the pulp, and it can be recycled very efficiently also. So it is coming from a renewable resource. And we know nowadays we all prefer paper cups also for um, drinking tea, or we prefer cooler, as we if we are given option कि plastic cup में पियेंगे या paper या cooler में पियेंगे, we always prefer for health issues also. And not only that, if this kind of awareness is there, so these can be recycled, these are recyclable material, so it can be recycled. Even paper straws are now available, paper tubes are now available, which are mostly the cosmetic products and are made of plastic. Their containers are made of plastic. It can also be substituted. Now, similarly, as you can see for energy also, the most efficient way is to increase energy efficiency. How? We are now almost in every home we are installing LED bulbs, not the conventional bulbs. Yes, the initial cost is high. Maybe this is of 10 rupees. This is of 150 rupees. It's okay. The initial cost is high, but it saves 75% of your energy. So efficiency is increasing here, and the energy resource is being less consumed. And this is true for every aspect. Another way is the decentralization of energy supply. That is, now we purchase electricity, or the electricity is supplied by the central grid. But if we can install solar power in our own rooftops of our home offices, then we can be energy sufficient, energy independent. We don't have to purchase from the grid, and we can be self-sufficient in terms of energy, especially country like India, where the solar energy potential is very high because the number of sunshine days are very high in our country. So we can make ourselves, households and business areas, energy self-sufficient by installing the renewable energy sources like solar panels, like maybe biomass-based electricity production, like methane generation, biogas production, and which can be used for energy production. And we can use appliances which are energy efficient. आजकल आप जब भी कुछ खरीदने जाओ, you will see the energy ratings, which are nothing but energy efficiency, that consumes less and less energy, and it is also profit friendly. So it's a win-win situation for environment, for us also. And in India, the renewable energy source potential is quite promising, but unfortunately it is not being installed in a very high capacity till now. We have more than 1,000 gigawatt renewable energy potential in India, but only 100 gigawatt installed renewable energy capacity has been installed as of August 2021. So it is only 22% of the total installed capacity. And we need, however, it has been increased quite a lot from the financial year 13-14 to till now, but it still it is only 22%, and we have still go more. We have to do more to use the renewable source of energy, which will definitely improve the pollution scenario as well as energy efficiency scenario, because we don't have much technological support of this renewable energy. Because this question arises, we if we have so much of potential, then why not? Because the cost of energy from a thermal power plant generated is much less. The electricity we get from thermal power plant per unit cost is much less than the cost of energy of production per unit energy production through renewable energy, because most of the renewable energies now are subsidized. So lots of technological research is also going on how to make this renewable energy cheaper than our conventional energy. So energy conservation, we all know, because this shift to renewable, uh, non-renewable resources to renewable resources will give us improved air quality. It will have less environmental damages. It will give us less carbon efficiency. That is, we will produce less and less greenhouse gases. So we'll become a more cleaner society in terms of carbon efficiency also. Then of course it will help to reduce the global warming and climate change, because once we start using this renewable energy, then there will be less and less emission of greenhouse gases. Now, another way to increase the energy efficiency is the smart grid system. As I was mentioning, smart home, which is using the solar energy coming from solar panel, and it is purchasing electricity from the smart grid, and it is also using non-emitting electricity, maybe this energy which is coming from the solar panel, which is a absolutely clean source of energy and absolutely renewable source of energy. If you can store that energy, that can be used to recharge our electric vehicles also, so we have no emissions, no pollutions. So such kind of design where both the conventional energy thermal power plant and the renewable energy is mixed and being used smartly, sustainably, then there will be energy efficient society and clean, less emitting society. And if this grid, whatever electricity we're purchasing from the grid, if it is a mixture of renewable energy and conventional energy, then also the situation will increase. And there can be like in foreign countries, they household can choose their electricity provider. There are many private companies also there. It's not government owned companies which supply the energy. There are many private retailers, and there are many retailers of energy. So you can choose from which one to purchase, and that will begin or initiate a competition, and that will trigger the energy sellers to uh, distribute the energy in more sustainable way, so that less and less energy is being lost. Till in India, the energy lost during this grid system is very high, 30 to 40% is being lost. So that loss will be minimized if they will have competition. And there can be some other options also, like fine tuning the old equipments, maintaining the old equipments, upgrading the old equipments, which eventually consumes more and more energy when they are becoming old. Their energy efficiency drops. So upgrading them or fine tuning them, use of superconductors. Superconductors are conductors which have no almost minimum resistance or no resistance. So they are very efficient energy providers. Then cogeneration. There is, as I was saying, there is a waste of heat in the thermal power plant. जब boiler में we are boiling the water to produce steam to run the turbine. So there is a lots of loss of heat from the coal thermal power plant. So if this heat loss from the boiler can be recaptured, then the heat can be used again to heat the water. And such kind of technology is now available. Tubes, there are now the water is not boiled in a boiler in most of the thermal power plants. They are passed through a tubes. Those tubes are kept in the insulated coal heated jackets, where under pressurized system also the steam generation is more and the heat loss is minimum. So such kind of technological innovations are there, and there are still research is also going on. In our residential sector, of course, the green buildings are examples of uh, energy efficiency. More and more sunlight can be used at daytime in offices, in commercial areas, in residential areas. In most of the offices, we switch on the lights throughout the day. But if the design is smart enough, like in a green building, the more and more sunlight is coming, the facing of the building is such, and the glass panels are in such direction that with season, as the sun orientation changes, the light also, the glass windows faces those directions, so you can get more and more solar energy. So you can use less and less lights uh, during the daytime. This is one of the example. There are many more ways, like the wall insulation will give you cooling effect in the summer months, so less and less use of air conditioners will save energy. In winter months, the cold air will not penetrate in if there is insulation cavity walls in your house, so it will keep your uh, uh, building warm. And as I have given you example of the LED bulb also, so maybe for energy efficient, if you want to buy a five-star equipment, then it may be the initial investment is more, but in the long run, your energy is saved and your cost of energy is minimized. Like, of course, these are the basic ways we all know. Instead of individual vehicle, more and more public transport system will save energy, as well as the material, the resources, material resources. Then the bicycle culture in campuses, in residential areas, or for nearby areas where you can commute through your office, commute to your office by bicycle. Then this bicycle culture is being promoted. It is now being promoted in India also. All the smart cities, they are having bicycle parking areas, as well as bicycle vendors and bicycle, where you can just put the you can pay and hire the bicycle for 1 hour basis. That is also there. So these are the uh, awareness and the options. Now the role of government and the motivation from the government, implementation of government is very much important. Government must promote the locally available renewable energy. For example, in rural areas, biomass is amply available, so biomass based energy production should be promoted, should be subsidized, and dependence on non-renewable energy should be decreased, which is in the case of India. We are so much, 60 to 70% of our electricity comes from fossil fuel based thermal power plants. So that dependency should reduce, and more renewable energy sources should be explored and promoted. There should be tax benefits, there should be rebates, and there subsidies. And energy technology, energy efficient technology should be promoted. And fuel efficiency standards for vehicles are being more stringent, and energy efficiency standards for buildings are being more stringent nowadays. So that is the government's role. And not only that, government should motivate the research and development also to improve the solar, I mean, the efficiency of energy and other ways of recycling and reuse. Tax rebate should be given who are using this recycling reuse products, and there can be like for material also there should be different tax for different. If it is a green product, then there should be rebate, or the product should have less tax, and those are which are virgin product, they should be made more costly, as they are more resource intensive, and those products which are using virgin resources can cost high, and those products which are being recycled products, they can be made cheaper. So people will be motivated to buy more and more recycled products. And there must R&D, lots of R&D funding is now being given by the government for waste to wealth generation. This concept, how the waste product can be made into useful products. And there will be, as I said, the energy efficient products should be promoted. There is a concept of not megawatt, that is the negawatt, that is which negates the energy consumption, like CFL of fluorescent bulb. And as I was saying, retail wheeling is of giving options to independent power producer from where you want to purchase your electricity. There should be tax exemptions, and there will be tax which who tax more tax for the products which are virgin, which are not using efficient appliances. And public transport should be more facilitated, more subsidized, and energy demand. For reducing energy demand and cutting the customer bills, there will be reward system, or there will be subsidiary system who uses the non who use less non-renewable energy. And for resource also, same thing, exploring new deposits, which it creates lots of problem into the uh, ecosystem also, that should not be promoted, because matter is not being lost, energy is being lost. So the energy efficiency is the only way, or the conversion to from our dependency from the renewable energy should be increased. That is the only way but for the matter, it should be recycled very efficiently, and those efficient technologies should be promoted. Recycling should be promoted, like metal can be recycled. Due to wear and tear, the recovery rate sometimes for some metals becomes very less because of rust problem, but some metals they have very high recovery rate. So that like gold, like platinum, because their wear and tear is very less, like as I said, aluminum. And consumer awareness should be there, and the concept of dematerialization and the minimization should be promoted. So this is an example of plastic recycling, and there are many options as you can see in the picture. Even tiles, floor tiles are now made of plastics. The pavement tiles are now made of plastics. So there are lots of product option also. Some person has made a boat out of plastic, waste plastic. Here the gardening is going on of plastic. So such innovative ideas, researchers should be promoted for reuse and recycling. These are the examples of used tires. Furnitures are now being made by used tires, as you can see here. Even the rubber part of utensils are being used. This is the wheel of the frame of the tire, which can be used as a hanging material. Furniture, even now the sole of the shoes are made of tires. So such for material, these are the options. Chemical intensive polluting materials can be substituted by organic material. For example, organic fertilizers can be a very good substitute for chemical fertilizers. Then, of course, the recycled, in case of matter or mineral, if our products are durable, they are reusable, they last long, then the throwaway mentality will decrease. Because if the products are durable, or in the long run, with minimum repairing or refurbishing, we can reuse that product, that will be more beneficial, and more, it will promote conservation of the matter. As you can see, and the mode design, now the, as I was saying, the minimization is one of the. Chargers are becoming smaller nowadays, our computers are becoming sleek, our phones are becoming sleek, as so less and less material is consumed. So minimization, even for hearing aids now, previously we used to have very high hearing aids. Now we have a very small one. Even for headphones, like one I am using, it is a very small one. So previously it was big headphones. So this kind of minimization will also help in to conserve our material. Now, this is actually, we don't have, we have to understand something, that the throwaway mentality, which is more prevalent in waste, they the products are not very durable. Within few years of use, they just throw away the products, and they buy news, which is creates extra demand on the society, and which creates extra demand of those materials, and more and more resources being used. So that is to be cured, the throwaway mentality. And we have to understand that in a formation of a product, there are many things involved, right from the, if we see the life cycle, right from the ore mining to the discarding and the landfill cost, everything. If we see the life cycle analysis of a product, then the throwaway mentality cost a huge economic as well as resource depletion threat. So this 5 E's mentality should replace the throwaway mentality, which is emotional, which you should think about the environmental services. You should think about ethics, that when to replace, how to use, and you should think about long-term economic values. And you also should think about the aesthetic value, because the dump years doesn't look good. So more and more you are dumping, you are creating solid waste, it will degrade the aesthetics of your city, of your outskirts of city, and so on. So this throwaway mentality should be replaced by your 5 E's mentality. So ultimate thing is, we should move from a resource intensive society, which is called as throughput society, to a earth wisdom society. So societal role is also important, because this throwaway mentality, replacement of this throwaway mentality, is depending on us. So the societal involvement is also required, where 8 billion individuals contribute waste heat, and 8 billion individuals contribute to pollution. Then the industrialized countries, they are very high waste societies, they are becoming unsustainable. So they are pressurizing for recycling, composting, disposal. If in our country also, lots of emphasis is being given now for recycling, composting, to reduce the consumption. We are still till now we are not that energy intensive society, but we should think that we should not become one. So we should think about earth wisdom society, and the ultimate earth wisdom society is of zero or low waste society, where everything is being reused, everything is being recycled, and there is no waste at all, or the waste product is converted into the composting, or in case of biological material, it can be converted into compost and reused in the field. So the Earth Wisdom Society or the Low Waste Society will only be successful when the recycled products are reused, they are purchased, or they are economically and sustainably applied instead of landfilling and incineration, where there will be total recycling and reuse of the materials. So thank you all. So we can have questions now, right, Sharad?
Yes. In the meantime, Dr. Tanushree, please stop the sharing, and all the learners are requested to put on your camera. Please put on your camera. Please.
Have any questions you
Yeah,
want
then we will have
to
discussion.
ask?
Yeah,
Yeah.
of course. Okay.
Nice to
Please put
see
on
you
camera.
all.
Mhm. Still, participation as women is very high.
Yes, that's
So
good. I
women are
want.
very much more concerned about sustainability, right?
Yeah.
So
I can see one case.
the male community should follow. Yes, Arun, you see, participation of women is also very high.
Okay, any questions or anything you want to ask or add?